This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you in part by the Pro Mathematics Academy. In this video, we'll be continuing our series on coordinate geometry, and in this episode, we'll be looking at the length of a line segment. Alright, so we've already been working with line segments A, B, C, D, and E, F, so we're going to continue. And now we try to apply the formula for a line segment using these coordinates, okay? So what is the formula for the length of a line segment? That it is L equals the square root of x1 minus x2 squared plus y1 minus y2 squared, right? Or the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? So either of these formulas can be used to find the length of a line segment. All right, so without further ado, we jump right in. Let's find the line segment. Well, the length of the line segment AB, here it's going to be the square root of, what's my x1 in A? It's going to be the difference between these two. So we have 1 minus 3 squared plus, in order to be consistent, let's use 2 minus 5 squared, right, which is equal to the square root of negative 2 squared plus negative 3 squared, okay? And when we square negative 3 and square negative 2, we end up with a positive 4 plus 9, which is equal to the square root of 13. And if I jump over on my calculator, I'll end up with 3.606. All right, units approximately, okay? Nice. Let's look at the length of the line segment CD. So the length of the line segment CD would be negative 1 minus 5 squared plus negative 1 minus 3 all squared, right? And if I evaluate this, I now end up with negative 6 squared plus negative 4 squared, which is equal to the square root of 6 squared, which is 36, plus 4 squared. So when we square a negative number, we end up with a positive number, all right? So this becomes the square root of 36 plus 16, which is equal to the square root of, jump over to my calculator here, square root of 52, which is equal to 7.211, okay, approximately. And for the last line segment, we can find this one using the formula, right? Or we can actually visualize this one in much the same way that we did the visualization for the midpoint, right? So let's see what the visualization result will give us. So let's look back for this point, which is 10, negative 5, all the way up to 10, 10. All right, so if we count the number of units, right, we should end up with the length for this line segment. All right, so after counting the number of units, I end up with 15 units, right? So this line segment is 15 units long. All right, now what will the formula give us? What will the formula give us? So let's see. The line segment EF should be the square root of, right? Here I'll say 10 minus 10 squared plus negative 5 minus 10 all squared, which is equal to the square root of 0 squared plus 15 squared, because when we square that negative 15, we'll end up with a positive 15 squared, which is equal to the square root of 15 squared, which is equal to 15. So the square root of 15 squared is equal to 15. So here we see that the formula gives us 15. And if we visualize this line segment, because it's vertical, it's a simple one to work out. But unlike that one, this one is a sloping line. So therefore, we can't immediately look at it and count up the number of units. But here we can count up the number of units because it's vertical. Likewise, if it was a horizontal line, we could also count up the units. All right. The last and final point to make an important note of here is that the formula for the length of a line segment is related to the Pythagorean law, right? So if we take this line segment AB, we should immediately recognize that, hey, a triangle can be formed if I put in a vertical line and a horizontal line. So here I put in this vertical line and I put in this horizontal line. And now what I realize is that the length of the vertical line is y2 minus y1. Likewise, the length of the horizontal line is x2 minus x1. So because we have these two lengths, right, the Pythagorean law says that if you have a right angle triangle looking like this side is A, this side is B, this side is C, then C is equal to the square root of A squared plus B squared. But here A is equal to x2 minus x1 and B is equal to y2 minus y1. Right? So we square both of these, add them, take the square root, and we realize that we end up with the formula for the length of a line segment. So the length of a line segment is directly related to the Pythagorean theorem. All right. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.